Okay, so this will be 4.4, and today we're going to be talking about scatter plots and lines of fit. So the gist of this section is going to be we're going to have data, we're going to look at that data, it's going to have a trend, and we're going to take what we know about writing linear models or linear equations, and we are going to write an equation that models the data given. This is 4.4. Scatter plots and lines of fit. And lines of fit. So this is really kind of the beginning of some vocabulary too that has to deal with statistics. You'll definitely get into some statistics once you get in high school, probably your junior year. There's also AP statistics you can take. But the first vocab word is correlation. And if there's a correlation between things, there's a relationship between them. There's definitely a correlation between the amount of hours I put in studying and the grade that I get on my test. Makes sense that the more that you study or the more hours you put in, the higher your score may be. They're correlated. There's a relationship between them. As the hours goes up, so does the test score. But what we need to remember is this is a relationship. Between data sets. Doesn't matter what it is. Problem will tell us what it is. Could just be XY ordered pairs. I'm going to draw three. First quadrant, coordinate planes. So here's what I have. I'm going to label them all. And I'm just going with first quadrant. We can certainly get data that goes into all four quadrants. But as far as looking at correlation, first quadrant will do us just fine today. So here's some data. I don't know what this data is. Maybe it is the hours you put in studying in your test scores. So here's some data. Now this certainly, from what we've been dealing with before, I don't want to connect these dots to make some sort of graph. We are looking at the correlation. We're looking at the relationship between those. And I'm going to look at it in terms of X and Y. And as I go out on the X-axis, as X is getting bigger, what's happening to my Y? Well, let's just say this is, we'll take this ordered pair right here. Let's say this is at 1.5, and then I'm going up to maybe 2.5, and then I'm going up to 3.5, and if I look, as I go out on my X's, my Y's are getting bigger too. There's definitely a correlation there. As X is increasing, my Y is increasing as well. And if I took a ruler and I said I wanted to model this, and I drew a line through there that represented that data, that line would have positive slope. It's rising, it's going up. This is called positive correlation. And the way I always remembered it is I just look at it. If it looks like a line with positive slope, then it's positive correlation. And I could have something that looks like this. Some data points. Now as I look at this, as x is increasing, as my x's are getting bigger, this is falling. My y is negative, it's going down. And if I think of this in terms of slope, your change in y over your change in x, if this is decreasing, it's negative. Over here, they were both positive slope. Here, my y is negative. My y is decreasing. So as x increases here, my y is decreasing. This line, if I drew that through there, not connecting the dots, but just a line of fit in particular, it would be trending negative. It would be going down. This is negative correlation. And certainly with data points, I can get an outlier point. I might have a point here. I might have a point out here. That's not really in the trending data, but in general, the majority of these points have negative correlation. As x is increasing, y is decreasing. And then I could have a graph where it truly looks random. There's no pattern. I can't tell. It's not trending up, it's not trending down. There's really not a pattern. I couldn't draw a line this way that represents it, the majority of the data, or this way. There's not a good line of fit that would be representative of that data. This has no correlation. No correlation. So there we go. What we are going to be doing is taking these points, and when these points don't have a pattern, the XY ordered pairs, these are scatter plots. A scatter plot is just, you start plotting it, and then we're gonna kind of piece it together as we go. So let's get some data, and let's graph it. So here's an example. I'm gonna just make an XY table here and put some points in. And whenever I'm presented with some data, I'm gonna look at it and I'm gonna see, try to picture in my head, get an idea of what's going on with it. And I'm always gonna be thinking as what I want this to look like, what it kind of should look like as I go through it. So there's some data points. And I can see, if I want to say, if I gave you the question on this, on your last test, your quiz, gave you some data, said, is this a function? Is it linear? Hopefully you would say, well, x is increasing by 1. I have a constant rate of change. But here, in my y's, I definitely do not have a constant rate of change. But I can say that as my x is getting bigger, my y is getting bigger. So I'm already thinking, I'm gonna have some sort of positive correlation. They're certainly not gonna all lie on the same line because I don't have a constant rate of change. It's gonna look like this. It's gonna look like a scatter plot. Here's what we do. These are instructions to graphing it. Because what we are gonna do is plot this data and we are gonna find an equation of a line that best represents that data. So I can then use that line to make further predictions, to extrapolate, to make a prediction in the future. So to write an equation for the line of fit. Step 1, make a scatter plot. So we're gonna make a graph. I'm gonna make an XY ordered XY coordinate plane, and I'm gonna look at my values of my X and Y when I do this. You want your graph to look good. You want it spaced out. You want it to be usable. I can see my X's are going up by 1s. My Y's, I'm going anywhere from 10 to 65. I may need to make a break in my graph. I certainly don't want to go by 1s on the Y and make 65 little marks on here for each unit. I could go by 1s on my X. Just some things to think about as I'm piecing this together. The more spread out you make your graph, the more accurate it's going to be. So I'm going to go probably right about to there. And then, let's see, I'm going to just give me a starting point here for a graph. I can definitely see its first quadrant because all my X's are positive, my Y's are positive. I will say this is going to be 0. I could go by 1s here, but I think I'm going to space it out. And I'm going to go every other. So I'm going to go by a half. So this would be 0.5. This would be 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. And I just like that better because it's more spread out. It's going to give me a graph that looks a little bit better rather than so tight right in this area here. When I look at my Y's, I certainly don't want to go by 1s. 2s would be 2. I would probably not even do 5s. I'm going to go, yeah, maybe 5s. Definitely not 10s because that would give me only 6 spots to get to that 65. I'm going to try it by 5s. 5, 10, 15, 20. I like this. 25, 30, 35, 40. That would be 50, 60, 70, 80. And I'll just go up to 90, although I don't have to go up that high. And now I'll complete that. There's my X and my Y, and I can see I've got a nice graph here. When I make my scatter plot, I got ordered pairs. I got 110 right there. I have 230 right there. 332. Well, there's 30. That's 35. This would be 32.5, somewhere kind of right below there. 442. Again, the same thing, a little bit below that half. And I have 565. And there's my scatter plot. And again, it kind of came out the way that I would suspect. I knew as X was getting bigger, Y was getting bigger, it should have positive correlation. It does. Here's where we want to draw in our line of fit. And the line of fit, again, is the line that best represents that data given. I definitely don't want to just connect these 3 points right there because it's not taking these 2 into consideration. The way I like to do this is I kind of take my ruler, my straight edge, and I line it up. And you want to take a peek down that. And you want this line to sort of split the difference here. Everybody's line of fit is going to be a little bit different because of the way you draw it, but they're going to be close. They're going to be close. And the steps that we use to get the equation are going to be the same. And when the equation is all said and done, the linear model, they will be close enough to use if you drew a decent line of fit. I certainly can't have a line like this. That does not represent the data very well. Something like this does. So I'm going to take this, draw it up, and then we're going to make some comments about it. Kind of analyze our line of fit. That's not too bad. And when I look at this, and here's where statistics comes in. This point and this point are on opposite sides of the line, and they're about the same distance away. You know, if you average that out, that line's a pretty good representation of in the middle. And again, I look at this point and this point. Again, about the same distance from the line and on opposite sides. Now I totally realize with 5 points, you're gonna have this odd one out here. That's okay. It's okay to have 3 on this side, 2 on this side. Depends on where this is. Even if this point was way up here, I still would lean towards positive correlation because the majority of my data is trending that way. That's a pretty good line of fit. And again, you couldn't have a line that looks like that, has a y-intercept over there. Definitely wouldn't be going this way, something that represents it. Because what we want to do now is write an equation for this line. Because if I have the model, I can make predictions way out here on the x. And in a real life problem, I don't have data for this, but that's what we want to use this for. Step 2 is what we just did. Approximate a line of fit. I'm just going to put in parentheses, this is what we drew. You draw that in, and that's what we did right here. That's an approximate line of fit. Step 3, you need to find points that lie on the line of fit that you just drew, and are, and I'm going to put this in quotes, exactly on a cross grid. Find points that lie on the line and are exactly on a cross grid, because if I want to write the equation of this line, which is linear, I need to have a slope and I need to have a y-intercept, and I'm going to get both of these algebraically. So I need 2 points that lie on the line, and I am looking for cross grids, meaning I'm looking for points that lie on the line and that are going to be spaced out. If I choose points that are kind of at one end of the line and the other, my answer will be more accurate. And it makes sense, because if I chose 2 points that are right here and it was just a little bit off, that is going to be exacerbated as this goes out. Choose points that are kind of far apart on the line. But you want to use the cross grids, and I say exactly because this is pretty close right there. And then when I look down here, I get some that are really close. This one looks closer than this one. So I want the one that's closest to the cross grid. I'm going to choose this point here, and I am going to choose this point here. You cannot use points that don't lie on the line to get your slope. You have to choose points that lie on the line. And this is how I said everything's going to be different. You're going to choose different points than I am, more than likely, based on the line of fit you drew and how you scaled your graph, how accurate you were. But the steps are going to be the same, and they will be very close at the end. I'm going to label these ordered pairs. This is 2.5, that's okay, is my x, and I'm at 30. This point is at 6, and I can see it's at that 65. Actually, it's not. It's 5.5. Excuse me. Accuracy, because I went by half, so it's 5.5. 5.5 and 65. So that was step 3. I chose 2 points that lie in the line, and hopefully you're going to say, hey, Mr. DeLong, we did that because I want to find slope. And you are going to do that with change in y over change in x. Here are my y's. And I'm going to go this way because I can see these y's are bigger, these x's are bigger. So I want to go in this direction when I subtract, so all my answers are positive. I know the slope of this line is positive. I don't want to mess with any negatives. So I will have 65 subtract 30 divided by 5.5 minus 2.5. Now we just do the math. 65 minus 30 and then I want to see what this fraction is going to come out to be, because we got to make the determination if we want to leave it as a fraction. 5.5 minus 2.5 is 3. 35/5 is my slope. I'm sorry, 35/3. And if I divide that out, I definitely get a decimal. It would go in there 11 times. You had to have 2/3 left over. It's 11.6 repeating. I'm going to leave that as a fraction right now until the very end. We don't want to round until the end, until I ask you, okay, once I have this equation, what's my y when x is maybe 50? And we'll plug in 50 for x, multiply it by 35/5, and then at the end we will round. So I'm going to leave that as a fraction for now. That's the first thing that we need, is my slope. And now I need to find your y-intercept, your b. And I will do that by using y equals mx plus b, and I will choose a point. I'm just going to choose this one because it's closer. I'm going to say I'm going to use the point 2.530, and I know I have an x and I have a y. I have a slope. 30 then would equal my slope. 35/3 times 2.5 plus b. And again, I am going to do this out. 35 times 2.5 equals 87.5 divided by 3, and it gives me that decimal again. So I'm going to kind of leave that. I am going to leave that. I am going to say 35 times 2.5 gives me 87.5. So 30 would equal 87.5 over 3 plus b. You would now have to move this over, so I need to subtract 87.5 over 3. And I'm going to get a common denominator, which would be 3. 30 is really 90/3, is it not? So I'm going to use 90 over 3. 90 subtract 87.5 would give me 2.5, and that's over 3 is equal to b. You now have the two things that you need to write your equation in slope-intercept form. That's the last thing that you are going to do. I'm going to write that over here. That is step 6. Final step. Write the equation. Y would equal, I take my slope, 35/3 times x plus my b, which is 2.5 over 3. And that's really close to being 3 over 3, is it not? Which would be about 1. And if I look at my y-intercept, or I just take 2.5 divided by 3, it tells me it's 0.8. If I look at my graph, yeah, these are by 5s, right? That would be 2.5. It's down here in that 1 range. That's pretty accurate. I like that equation. I'm going to box it in, and that's my answer. What we can do then, and what we will do, is take this equation, and now I could say, based on this model, what is y when x is, I don't know, 10? You take that 10 plug it in for x, 350 divided by 3, add about 1 to it, and it should be there. Somewhere way out here. The data's trending that way. That's what we use it. What are you going to be asked to do? This right here. There's one problem in your homework. You're given the data. Follow these steps to write your equation.